just share my screen. Okay, is my screen visible to all of you?
Yes.
Okay. Okay. Good evening, friends. Thanks for joining in. So the agenda for this session is to carry out revision for quiz 2 and for the LLM. So, like I had mentioned in the WhatsApp space, that week 7 and week 8 mainly it is about theory. So, covering theory is not feasible for me personally. So, what I thought that what we will do, we will have a look on the GAs of week 7 and week 8, and then we have got only one previous year question paper of LLM, which is same for all the sessions, okay, in that term. So then we will have a look on that PYQ, and we will discuss, okay, some contentious issues, some debating issues. And is that okay with you, or any input from anyone?
It's completely fine. Just a question. The
Yeah.
syllabus is just 5 to 8 now.
Just 5 to 8. Somebody had mentioned in the WhatsApp group that Swarnim had said this, that it will be 5 to 8. But personally, I recommend that to answer the questions, your
Mm-hmm.
concepts of week 1 to 4, for example, what is a tokenizer, what is the size of a tokenizer, what is
Mm-hmm.
the context length. So that should be clear to all of you. That is my
Got it.
own my appreciation, because in some questions, okay, that might come handy. So please go through the basic concepts of the transformer. Okay, what is the MHMA, what is the MHA, MHCA, what is happening in the FFN, what is the output layer, what is the embedding layer. Okay, so that will come handy. So without taking much time, I will straight away jump to week 7 and week 8 GAs. I hope this is clearly visible to all of you.
Yeah, exactly.
Okay, okay. So I'll cover here from the starting that there are certain things, okay, which will highlight here only, that we had BERT. BERT was an encoder only model. Okay, only model. And in BERT, what used to happen, that this is the encoder. We used to mask certain tokens. So for example, it is like I am going home. So I mask A, I mask home, and then when I calculate the loss for the updation of the parameters, I take the loss with respect to only these tokens, mask tokens. Is that okay? In BERT.
Hmm.
And this we call it as a masked language model. But when we come to GPT, GPT is a CLM, causal language model, and it is a decoder only model. So what it is doing, we are giving input and it is predicting the next output. So this output becomes the input for the next one. This becomes the next one. So in this GPT, there is nothing masked. Okay? We used only masked during the training MHMA. During the training, if we are using teacher forcing. In case we are not using teacher forcing, if we are using only auto regression, then there is no marks. Is that okay, Lavlinji?
There should be a mask always, na, in case of
Okay.
GPT.
Okay. So, but Lavlinji, if we are using, for example, auto regression, not during training. Okay, during the training, mask is mandatory. Mask
No,
is
in
used.
auto regression, you will have a mask always will be there.
Okay, so it will depend. Okay, for example, there are various strategies. One strategy is that you are passing the entire sequence, then we require a mask. In case you are passing one token at a time, then that is the time when the mask may not be required.
I think mask is always there in case of
Okay,
GPT.
okay, okay. Then third part we come to BART. So BART is like a encoder decoder model. It is an encoder decoder model, but it utilizes the both the concepts. So in BART, what happens, in the encoder you give corrupted input, so like what we were doing in the BERT, and in the decoder, unlike the BERT, you calculate the loss with respect to the entire sequence which is generated. So that is the difference. In the BERT, okay, what we were doing, we were calculating only the loss with respect to the, we were predicting only the masked words. In BART, it is an encoder. You corrupt okay, inputs and you generate the entire sequence. And for updation of parameters, you take the entire loss. So that is the difference in the BART. Okay, so these are the three basic differences between BERT, GPT, and BART. Now, thereafter, this entire week 7 was about how to compare the models, what was about the prompting and all that. So that was all theory. So I will straight away jump to GA.
Sir, in week 7, or I don't
Yeah,
remember, there was something called Sentinel tokens.
Sentinel tokens. Yes. So
So what
Sentinel
is that?
tokens. Okay. So Sentinel tokens are like what? Sentinel token is like I am going to home, which is in Delhi's central area. Okay. So instead of masking a word, this is a sentinel token. For example, I will mask, for example, going to. So this becomes one token. Okay. I
Okay.
mask one central area. Okay. I mask, for example, which is in. So generally, this proportion is very high. It is not so high in actual cases. In actual cases, it is just 20 to 30%. So this is a sentinel token. So this will become, so when we are doing, for example, in if we do in BART or the base in the, okay, I'll cover something here. In the baseline model, which was used in the week 7 lectures, in Sentinel, again, like BERT, it was only predicting the mass Sentinel tokens. So loss was being calculated with respect to this only, like which we used to do in the BERT.
So
Okay.
even in the BAT, only the Sentinel tokens was going to be predicted. I mean,
No,
not the
no,
whole sentence.
no, no, no. In BART
Okay.
full sequence, in the baseline model, which he had covered again, there is a baseline model which is like a BERT base, okay,
Okay.
with 12 layers and 12 layers. It had again this Sentinel tokens.
Acha.
Now we come to this is the baseline model. Okay.
See, all of you must know what is the architecture of BERT, BART, T5, GPT, and attention paper. Okay, which of them are decoder only models? Which of them are encoder only models? Which of them are encoder and decoder models? Okay, this is something, if you remember this thing, then a lot of your subsequent answers can be, made very, very easily coming out of this architecture themselves. Wherever you have a decoder, you're actually generating the text, entire text. So whenever you have a decoder involved, you will have auto regression and you have generation of text. All those things will be applicable over there.
Okay, so I will amplify what Lavlinji has spoken. So we have got three types of models: encoder only, decoder only, and encoder decoder. So if you see encoder only, primarily we have got only BERT. There are very few encoder only models. If you go to Hugging Face also, you will find only this. If you go to decoder only, there are many models. So entire GPT 1, 2, 3, they are decoder only. Your T5 is a decoder. Your Llama is a decoder. And when you come to the encoder decoder, we have got only BART only. Okay.
No, your T5 is also a encoder decoder thing.
Okay. So we'll see that. Okay. If I'm not wrong, okay, T5 is also a decoder only with a task and sentence. We'll check that. I have got in some slide here. I've included that.
Shall I quickly show a thing which is showing the difference of these models? It will
Yes.
give you people quick revision.
Yes, please. Yes, please.
Okay,
Let
I'll
me
quickly
take my
show
screen.
some. Yeah. Is it visible?
Yes, yes, definitely.
Okay. So BERT, it will be good if you also remember these names also, because answer comes from the name itself. It is a encoder representations from transformer. So it is encoder only thing. It has the objective is known as masked language modeling. Okay. It is predicting only the masked tokens. Okay. BERT is predicting only the masked tokens, not other things. Attention is bidirectional over here. So you have got input is like this mask, and then it will predict only one word, which is corresponding to this mask. That's all you have got in the BERT. When you look at the BART, again, the name says bidirectional and autoregressive. So it has got both encoder and decoder. Both are there. Objective is denoising autoencoder. Wherever you see the word denoising, it means you are corrupting the input. Okay, you're corrupting the input through some mechanism. Either you're masking the tokens, you're shuffling the content, or you're deleting certain things. That's how you're doing it. And job here is to reconstruct the original sequence. That means you have to generate the text. Okay. So it is a BERT style bidirectional and GPT style autoregression. The combination of both the things is there. Now over here you see a sentence which has got a mask, but then all these words are also in a random order. They're all shuffled. So it is generating the entire text. Unlike the previous one, where it was generating only one word, which has got a mask. If you see here, the sentence order of words is correct. Only one word has been masked. Over here, the order of words itself has been jumbled up because we are corrupting the sentence. And then there is one word which is completely masked. It is generating the entire sentence. Okay. Then you have got GPT. It is a decoder only thing. Objectively CLM. It is predicting the next token given the previous ones in autoregressive. This is something you have seen. I will not talk about this GPT thing. T5 is your text to text transformer, transformer. Now this T5 is essentially these 5 T's. Okay, text to text, transfer, transformer. So text to text means you're giving a complete sentence and you're getting a complete sentence output. Transfer from the encoder to the decoder. So it's an encoder decoder thing. And this is what is known as just sequence to sequence. It is using MLM, masked language modeling. It is doing translation, summarization, everything in this way. It is corrupting spans of text. If you remember in the previous ones, we are corrupting only, one word. But this particular thing, it can corrupt multiple words. As Lalit was showing you, it can corrupt a sequence of words, 2, 3 words, 4, 5 words. It can,
So it
mask.
is a sentinel token. Right?
Yeah, that is where it will be replaced by the sentinel tokens. Okay. And there are certain rules for those sentinel tokens. And then we have got the attention paper, which
Sir,
has
one
got,
minute.
yeah.
So the only difference between the T5 and that BERT means MLM किस में होता है? एक तो T5 में होता है और किस में होता है? BERT या BART?
BERT के अंदर MLM है.
अच्छा.
ओके. BART में जो है हम डीनॉइजिंग कर रहे हैं.
अच्छा, तो BERT और जो T5 है उसमें डिफरेंस यही है कि BERT के अंदर हम सिर्फ एक टोकन को मास्क करेंगे और T5 के अंदर हम मल्टीपल जो सीक्वेंस ऑफ टोकन्स है उनको मास्क कर सकते हैं.
Plus, this is a encoder decoder architecture.
अच्छा.
It is generating the entire sentence, whereas this guy is generating only one word. It is an encoder only model.
Yeah.
Okay. It will be good to just draw out small, 4 or 5 boxes so that you can easily remember them. And then this is your attention paper, which is again an encoder decoder thing, sequence to sequence. It is used for machine translation kind of things. And all of them are using actually cross entropy loss. And this is your input and it is generating the entire output. Okay, so here is the comparison. BERT is encoder only, BART is encoder decoder, MLM, it is predicting the missing tokens, it is reconstructing the entire signal because we're talking about denoising. GPT is decoder only, T5 encoder decoder, transformer, the original transformer is also encoder decoder. Okay, I'll quickly rush through some more stuff before I give the screen sharing back to Lalit. And I will also, I have posted this document, I'll post it again in the group. So BERT has a cross entropy loss, and loss applies only to the mask tokens. You're using only mask tokens. You're counting the loss only for the mask tokens, not for the rest of them. So your loss is actually sparse because out of 10 words, only one of them may be masked or two are masked. In case of BART, again, all of them actually have got cross entropy loss, but you're computing the loss over the entire sequence. Okay. In case of GPT, again, it is a cross entropy loss, and you're applying this autoaggressively to the next token. So essentially, you end up doing it for the entire sequence itself because one by one, you're doing it for the next token. And T5 is again, you're predicting the target sequences, and loss is also happening over the all of them, and cross entropy loss. There are some fine nuances on these loss things, so you may consider reading about that. I'm quickly rushing through it because I'm just giving you topics that you need to study. Okay, then you can read these topics yourself, and this document can also be shared with you. Cross entropy loss again for the this transformer attention architecture also, and it is applied only for the decoder phases. And this table is there for the summary. Activation functions. BERT is using GALU, and BART is using ReLU, and then T5 is using ReLU, and then GPT is using GALU. Now you may be wondering, how do you memorize these things? My take is that okay, in general, GALU is more computationally expensive. ReLU is easier to implement, but GALU is more powerful. So when you have architectures which are only encoder or only decoder, they are using the GALU function because your computation is less in that case. And you need a more expressive, more powerful function because you're not using the full encoder decoder blocks, only single block is used. And when you're using a full encoder decoder only, encoder decoder models, like in case of BART and T5, then you're using the ReLU because you have more computations happening. And because of the full architecture of both the blocks, maybe a less powerful function may be usable over there. This is just my interpretation. And I hope that I'm correct on that one. And I've also written this thing over here. BP and all these things, I believe you have already covered in the previous sessions, Lalit. So this document is there, you can have a look at it. I'll just share one more thing. Yeah, these are the special tokens. This is something you may get familiar with, like what are the special tokens for each of them. Okay, I'll show you a table at the bottom. So in case of BERT, you have got a CLS as the starting token. And for classification, this CLS is actually standing for classification. All your classification related outputs are coming out corresponding to this token. You have a separator which is used as a separator as well as end of the tokens. And there's a mask which is used for masking, and then you have got padding or pad. You might have noticed that when you were doing your implementation of the programming assignment, in some of them padding tokens are there, and other ones padding tokens are not there. The most recent that we did was GPT. It did not have any padding tokens in the tokenizer. Okay, but BART is using this, within Angular brackets, S and /S as the starting and end tokens, and then so these are all using different conventions for their special tokens. Okay, T5 has got this thing, and T5 have got this for masking this extra IDs there. This is what is the Sentinel tokens are there. I'll talk about them a little bit later. And GPT in that sense just have an end of token, and then there's also a start token, which may be typically from a, see, there's one more thing you have to be careful. There is something written on the internet about general things, but you have to answer things in context of the slides that have been taught to us. So in context of those slides, GPT is supposed to have a starting token as go, or maybe a start, and then it has got this end of text or end or EOS, those kind of tokens might be there for GPT. Now these Sentinel tokens, as we mentioned, T5 is the one which is using Sentinel. And here is, example, the quick brown, this is actually a couple of multiple words are there. Brown fox jumps. So there are 3 words. These 3 words are replaced by 1 token. Okay. And then this one is single word. It is replaced by another token. So you may have a span of tokens which get replaced by a single one, or there may be just single word which is replaced by another token. So these are special tokens. These tokens are not used as part of your text. Okay, they have a special role. They are part of the vocabulary, but they're not supposed to be appearing in your text. So during the output, what it is going to do, it is going to say this is my first token and this is the predicted text for this token. This is my second sentinel token and this is the predicted text for this one. And then in the end, it will add one more sentinel token, which is saying, okay, this is the end of the output. Okay, so this is how your entire output gets handled. So this is your training time and this is your generation. During the inference, it is capable of doing the entire sentence, but during the training activity, this is how it is handling things. Okay, there are some rules. First rule is every sentinel token must be unique. You cannot repeat the sentinel tokens in the sentence. They must be unique. Okay, if your ID has been used once, then the second token should have a different ID. They must be in the ascending order. So these tokens have a certain order. In the questions, they're using X, Y, Z as the order. So then you have to ensure that X is appearing first token, Z is appearing at the end, not in between. They're not supposed to be overlapping or repeating. Okay, this is just a repetition of this thing that each of them should be unique one. Okay, and in between there is a, I put one question also. You have to be careful with these sentinel tokens because they are not part of the text, but they're part of the vocabulary. Okay, somewhere I mentioned that question. I don't know where exactly is it. In GA 7, question 4 is talking about whether the sentinel tokens are part of the vocabulary or not. Yeah, this is the one. Okay. So they are part of the vocabulary because every token has to be part of the vocabulary, otherwise it cannot be used. But they are not supposed to be appearing in the text because otherwise system will not be able to detect whether it is part of the text or it is a special token. Okay, so that was a quick tour of the entire course. Over to you, Lalit.
Thank you, Lavlinji. Thank you so much. In
Yeah, I'll
fact,
post
what
it into the
yes,
that group.
yes. In fact, what you covered again in a nutshell is the entire thing of week 7 and 8. So, just for the completeness purpose, I will just again cover the week 7, so the things can become clear. And yes, okay, T5 is the encoder decoder model. So this is one question again, which is slightly. I found that it is. I have got doubt in this question. This is the first question of week 7. Consider a vocabulary V. It has got a start, building, character. A is astronomy, science, experience, natural, and. Assume that the BART model is being trained using BART's is denoising objective, and the original sentence is start, astronomy is a character building experience, and the corrupted sentence is this. So they have corrupted, okay, this here and this mask, and the prediction probabilities outputted by the model are given below. The zeroth row of the matrix is the output probability distribution by the model given the spatial start token as the input, following the greedy search decoding strategy. So greeding, what does it take? It takes the maximum probability for the next time step. So if we see here, when we give a start, the maximum is coming at 0.41, which is for astronomy. And if you, so astronomy has come. So for the next step, it will take astronomy. For astronomy, the maximum probability is coming 0.43, which is for is. It means this mask which is there, and it is a model BART. So in BART, what do? We take the entire sequence loss. Now here, for the next, it will take is, and here the maximum is coming from 0.29, which is for A. So this mask is A. Then it takes A, next is 0.48, which is for character. So it is correct. Next is character, it takes 0.29. Then for character, it starts as a character. So start astronomy is a character. Building, character gives building, and building gives maximum at 0.23. And then building exercise gives maximum for 0.3, which is end. So when we calculate the loss, as per the slide here, the loss formula is 1 by n sigma ln of y hat, or here the loss here, probability which we are getting, minus ln y hat. So in this case, if we take without end and we don't take, then it becomes 1 by n, 1 by 7. We have to take natural log of these values, and the answer comes 0.91. So I did some research today in the morning, because Lavlinji had told me that why I have not taken AND. So if we take AND, then we will take minus ln of 0.3 also. And if we take this, then answer becomes around 1.3, which is not matching the expected answer. So when I did research again, then I could find out that in many of the models, they say that AND token is not taken. So this is one question which is doubtful whether we take it, because it has not been covered in our course. So Lavlinji, can you throw some light on this, please?
Actually, problem is not so much for me whether end should be taken or not. The problem is that you're counting it in the denominator, but not counting it in the numerator.
Yes.
If end is not there, it should be 1 by 6. Over here, we have 1 by 7. So depending on the type of model, actually end may be included or it is not included. If you include end in the loss calculation, then the model will learn to, detect the end also. It may tend to generate end very quickly, and it may prioritize, shorter sentence generation rather than a long sentence generation. That is the reason in the auto regression mode, they do not want that end should be used as part of the loss. And sometimes, and this is not related to the course, if you're working on a particular model where you want to have very precise control on the kind of output which is being generated, typically, there is a certain protocol which has to be generated. Then that fine control on the end is very, very important. In that case, they typically will be using end as part of the loss calculations. So usually they ignore the end because they do not want model to be learning the end, because end is occurring, too frequently. It is part of every, sample has got end. That is not the case otherwise. In all other sentences, there's rarely a word which is appearing always, but the beginning go and end is actually appearing in everything. But go is used only as an input. It is never coming out as output. So then end is the only thing, only token which is always present in the output. They do not want it to be, learning it, and that's why they are trying to exclude it. Now I just have to, figure out the good answer, like why are they excluding it and why are they including it in this case. For the timing, I will say the way it has been done, we have to kind of mug it up and do it exactly like this for our exams.
So for quiz, okay, we will remember this, okay? This approach. And because why we will follow this approach, because then we can contest on discourse.
Lalit, the N here would be 7, right? Start astronomy is a character building exercise. That's 7, right?
Yes, 7 includes the end.
7 is not including
Not including
and
it.
here.
Is 7 not including the end?
No.
No.
How many words are generated?
So see 1, 2, 3, 4, 5, 6, 7. So start gives astronomy. Astronomy gives is gives A gives character.
No, you have to either you count at the bottom or you count at the top. You can't be mixing them.
No, like
If
this.
you're including start,
Yeah.
then you have to ignore the end. Okay, but we are talking here about the outputs. Start is not appearing the output.
Okay, so these are the outputs. Astronomy is a character building experience and.
So there are 7 outputs generated, including the end.
But loss for end is not taken.
Yeah, but we are counting it as part of the denominator.
Yes.
So that's a kind of a anomaly. We don't know what is the reasoning behind it.
Yes. So today what I will do, I will flag it to Arun here. Let's check for his reply.
Yeah.
Until then, so that's I wanted to cover that this question has got a doubt. Okay. Then the second question is assume that we have 12 sufficiently large unsupervised NLP data sets for different tasks like sentiment classification, texture entailment, language understanding, and so on. Suppose we take all the samples dropping labels from these data sets to train the GPT model using the CLM objective. Then which of the following transferred learning approaches are appropriate to transfer the knowledge to any of these 12 downstream tasks? So this was covered in the lecture that in case we have got a large data set and we feed it to GPT. So GPT, what it uses? It uses CLM. So in the pre-training, it learns the context and it can do the downstreaming tasks which are there with a zero shot capability. Zero shot means that we don't fine tune it, no fine tuning. So it is capable of that, and they have done it here in GPT-2 or something. However, if we do the few shot learning, it means we do some fine tuning. So that is also applicable, that also can be done. And full fine tuning, that also can be done. Lavlinji, can you add on to this?
This is which GA7?
GA7. This is the question number 2. And this is directly from the lecture again. So he had covered that for the GPT, for a CLM, like we are given a GPT model like using the CLM.
For this thing, you just need to remember that these large language models, okay, when they have been trained with huge amount of data and huge amount of parameters, so what they realize that these models have got a special ability for this zero shot learning and few shot learning. Okay, so although this was not part of the original ability, but then afterward they discovered that they're good at these kind of things. So it simply means that you do not have to retrain it, and it still has the ability to do zero shot as well as few shot things. Fine tuning can be done on any model. Okay, so fine tuning is applicable for any model.
So there's no parameter update, right?
In zero shot and few shot, you're giving the examples as part of your prompt itself.
So
okay, there's no. When you go to ChatGPT, you can give it a couple of examples as part of a prompt itself. If you do not give any example in the prompt, you just ask it certain question, that is your zero shot. If you're giving it couple of examples and then asking it to answer for those examples, that is known as few shots. In both the cases, ChatGPT is not learning, updating its parameters. It is just generating the text based on your prompt.
In few shot, the GPT or models can learn how we want the output to be.
No, they're not learning anything. In zero shot or few shot, they're not. There's no learning happening there really. It is just generating the text. Okay,
So
there's no updation of parameters happening in few and zero shot.
So suppose in few shot, we give some input to the model, and in the next step, we again give some like question like that. Then what should we expect? Like in the previous step, we gave
It will
some.
forget. Every input that you give to the model is independent.
Okay, okay. So it will forget because no weights is getting
No
updated.
weights are there. When
Yeah.
you're using ChatGPT as an application,
Mhm.
it is remembering your conversation history and it is sending all the data automatically to the model. But
Then
as far as model is concerned, every input is independent. There's no memory in the model.
yeah. Okay. Thanks.
Okay. Okay, so this is covered. Okay, next is the strikeout words. Okay, this is directly from the CLM, sorry, Sentinel, that already Lavlinji has covered. So this is the struck of tokens, and they have given that which of the following represent the correct target sequence with Sentinel tokens to the baseline model that uses the pre-training denoising objective. The characters inside the square bracket are the Sentinel tokens, and the Z represents the end of the Sentinel token. So Z is also a spatial token, which means it is the end of the Sentinel token. So if we see the choices directly, this choice, it does not have Z, it does not have Z, and the last one does not have Z. So straight away we can stuck it off. We see the first, so V of signs of W contradictory attitudes, X counterintuitive they may be, Y how deep truths are winnowed, and Z, so this is a correct one. Now these are like what we used to do the encoding part again. So this we have used VWXY. This can be also used as ABCD. However, we cannot use A here because it has got the same encoding. So if, for example, in PYQ there is a question in which one of the choices is like that, that will be incorrect.
So you need to distinguish between this, when they're putting things in a square bracket, it is no longer a X or a Y or Z. It is a different token. Okay, X inside a square bracket and plain vanilla X are different things. They're just using this notation to say that this is a special token. Important thing is all these tokens should be unique. There should not be any duplication of these tokens, and their sequential order should be preserved. Like XYZ has a sequential order, ABC has a sequential order. It should not happen that Y is appearing before X. And at the end, you should have a terminating token also.
Okay, so this is the example where your sequence has been changed. Okay, so sequence was off signs has become VW, X will come here, so the sequence has been corrupted. So that's why it is incorrect. Just know what Lavin is saying. Okay, next one is the statement that the spatial sentinel tokens used in the denoising objective or T5 models are part of the vocabulary. So just now we can realize that all these tokens which are there, which we are using X, Y, Z, or these are your part of vocabulary. So that is true. Any question till now with anyone?
Sir, in the question number 3,
Yeah.
suppose the sequence of characters are repeating, okay, and we are masking every time. So will it have the same like representation? Like off signs is repeating 2 times, suppose in the input, and after noising, will we encode the off signs is same as V for multiple times? We could do that, right?
See, as far as the input text is concerned,
Mhm.
there are no rules about that. Okay. There are no rules about the input text. Rules are only about the Sentinel tokens. That Sentinel token should be unique. You can have any part of the text getting masked, even if with the same phrase is getting masked again and again. Okay. And each span of mask should be represented only by one token. So sometimes you have sentences which have got, same 2-3 words appearing multiple times. So it is fine to mask them multiple times because each of them is treated as an independent activity.
Okay, so you are saying we should mask it separately.
Yeah, because it doesn't care. It is, as I said, it is saying that this is the place where something is missing and I have to generate it.
Right.
So if you are missing something on the another place also, then you have to ask for generation over there also.
So
Otherwise, how are you going to say that?
yeah, it should be repeated. Yeah, as well.
Yeah.
Okay.
Yeah.
One more question here. Suppose in the first option, suppose we interchange square bracket V and square bracket W, then the answer will be incorrect, right?
Yeah,
Yes.
because your sequence is violated.
Okay, yes, okay.
Okay. Okay, and what Lavlinji just mentioned, so we have to understand that basic concept also bidirectional. So here home and this home, the context which you're learning is different. It will learn from here and this is learning from here. That might be one of the reasons that this token and this token will be different. Is that okay?
Yeah.
Yeah. Next is mathematical. A data set contains 66 billion tokens. Suppose we want to train a model for 1 million steps so that the model will see at least 5 billion tokens. Then which of the following is appropriate batch into token size? So if we see the first part, 8 into 128, 8 into 128, we train it for 1 million steps. So 1 million steps is this. We multiply, we get 1024 million. 1024 million is 1.024 billion. But we want to see 5 billion. So this 8 into 128 will not be able to see 5 billion tokens. 64 into 128, it is around 8.1 trillion, which is more than 5 billion. So it will be able to use 128 into 512. Again, it is more than 5 billion, 5 billion. So basic concept, what they are saying, that for example, your data set has got, they say, for example, 2 to power 10 tokens. And your batch size into T is, for example, 2 to power 4 into 2 to power 8, which becomes 2 to power 12. So when you train this data set, how many tokens you will be used if you are using training step, for example, 2 to power 4. So your number of tokens seen will be 2 to power 4 into 2 to power 12. This is 2 to power 16. This is the concept. Is that okay?
Can you repeat once more?
Okay. So number of tokens which are seen, it depends on your batch size into token size. Okay, and how many training steps you are having. For example, I'll just give you an example that your token size is, for example, 1024. Okay, and you are passing so many batches. How many? For example, 2 to power 4. So in one training step, you will be seeing so many tokens. And if you do, for example, 2 to power 8 training steps, so how many tokens you will see? 2 to power 8 into 2 to power 4 into 1024.
Right, right. Okay.
Okay.
Yes.
And from here only, I'll cover some concepts of overfitting. Like if you have got, for example, your data set has got only, I'm just giving you an hypothetical example, 1024 tokens only. Okay, your batch size is, for example, 2 to power 4 and your token size is 2 to power 4. So this becomes 2 to power 8, which is 16 into 16 is 256. Now, if you train this, for example, 2 to power 4 training steps, so what will happen? 256 into 16. 4096. It means every token it has seen how many times? 4 times.
Yes.
And it will memorize now. So this will be the case of for overfitting. Okay. And this happens, okay, just remember from the concept point of view, when number of parameters is more than your data set token size, then your overfitting will happen. Is that okay, Lavlinji, this explanation?
When your number of
When your number of parameters which are there, which is more than your data set token size, then your overfitting happens because the model learns, memorizes.
yes.
Okay. Anyone, any question in this, Akya?
So this thing true for all the cases?
This is true for all the cases, overfitting.
Okay.
Okay. So I think this was the last question, or there is any other question? Okay. Next question is also there. Consider fine-tuning the T5 model. So like Lavlinji covered, T5 is an encoder-decoder model on a Sentinel classification task. The T5 model was pre-trained using C4 dataset, collinear dataset. Suppose in the original dataset, the positive samples are denoted by integer 1, negative are denoted by integer 0. Choose the necessary modifications that one needs to perform to use the T5 model. So remember T5 model which was there, it is text in and text out. Okay. So this text in, text out, we can have a 0 and 1 also, and we can also train on negative and positive also. So they both are correct options. Is that okay? Any question on this?
No.
Yeah.
Do you all understand what was the main difference in T5 and other models?
Yeah, T5 basically uses your Sentinel-based tokens, right? Others was like mask-based tokens.
But
One
other than
text is
that,
not included.
other than that,
Other than that, your architectures, except BART, most others are not using the entire transform architecture.
think
T5
from a
also uses text to
think,
text.
think from a training data perspective. See, T5 have this concept of a prompt.
Okay, so the prompt was into the training.
So prompt is part of the training itself. Whereas in all other models, prompt is not, concept of prompt is not there. Those models were being trained for some specific, the fine tuning was happening for some specific tasks. Over here, you don't need to do fine tuning because as part of the training data itself, you are saying in the beginning, translate this text, summarize this text, classify this text. You're giving those instructions as part of the training data itself. So that is becoming the key difference. So with this approach, whether you have got labels called 0, 1, 1 more, or whatever it is, you just have to provide it as part of a training data, and it can do the sentiment classification or any of those activities.
But
The
this
main
same
difference,
means
sorry,
this same thing is not in GPT. In GPT also we can write like classify this text and then write the text and it will start generating the next tokens.
No. Shubham, okay, in GPT, how do we use a sentiment classification? In
Means-
GPT, the final output which is there, GPT is a CLM.
okay, just hold on,
Yeah.
The GPT that you're seeing today, in the GPT that was taught to you, have very different set of parameters.
Okay.
Okay, so when you have a 100 million model, 100 million parameter model, or you have got 170 billion parameter model, their abilities are very, very different. Because you have to think about it. 7 years back, what was happening and what Professor Mitesh has told us was something, what he has taught us is something which was happening 7 years back. Okay, 5, 6, 7 years back. That was, how the things were evolving. So at that time, the original models were not so popular. GPT-1, do you remember anything about GPT-1? The first model that you guys saw was GPT-3, 3.5. Prior to that, you would not have heard of GPT at all.
I was using GPT-2 to find out which banks are the most useful to steal from.
Prior to that, BERT was there. People knowing about BERT because when Google brought out BERT suddenly, and there was a whole sequence of those cartoon characters came up around that time because the name BERT actually was that cartoon character. Okay, you must be remembering, knowing that why how all these things have been given the names of Llama and Lambda and BERT and all that stuff because these are all names of cartoon characters. Initially, that is what was happening at that time. So at that time, they were training the models, and already these models were looking quite good enough, but then they were fine tuning them for specific tasks. And then this T5 people, they did a huge amount of study that okay, what is it that is making difference? Is it the data set size? It is the way of training. It is the number of iterations, and that is what is happening between your week 5 and week 7 or 8. In between, there a lot of this kind of stuff has been shared by the professor that these are the things which are making difference. But actually, there was a dedicated paper which was written on this topic that what is it that is making difference between the models. So then they decide that okay, we can consider everything as a sequence to sequence generation. Okay. Now you do not know today that GPT is being trained with this kind of instruction data. At that time, it may not have been trained because right now this is only about how you are putting this data into the training itself. So if GPT today has been trained with this kind of data, which is clearly saying that okay, summarize this thing, or do a translation of this thing, then it can handle it. And today's GPT versus original GPT, there's a huge difference in terms of data as well as in terms of the number of parameters. Just try to plot it on a graph. 100 million versus 175 billion. The problem with these big numbers is that we are not able to imagine that how big is the difference. We normally think that 100 million and 175 billion, oh yeah, there's a difference. But then just try to put it on a scale, then you will realize that okay, one of them is just a dot and other is a very, very big circle. On a slide, just try to draw two circles or three circles. One is showing 1 million, other is showing 100 million, and other is showing 175 billion. Then you will realize that what is the difference in the scale.
Okay, thank you, lovely Ji. Any query here till now with anyone's point? So just to clarify, in the CLM, in the GPT-1, we were using this last output which we are getting for the sentiment analysis. We put one output layer here, get two values, and we train we train on the label data, and we can classify yes or no, 0, 1, N or P, or any number which are different. So this was being used. So this okay. Now we come to, suppose we have two models, a decoder model with P parameters and encoder decoder model with 2P parameters. Then both models computational cost under the T5 network framework is the same. So answer for this is true. Why it is true? Anybody? Can anyone answer this? Davinci, can you throw some light on this?
So is this like in the decoder model, the input? I mean, it will be like input output both. So it will like two times output will get 2p as well as like in the encoder decoder model. I don't know if that makes sense.
Yes, computation which is happening, they are asking about the computation.
Yeah.
Like in the decoder, what is the computation? And in the encoder, this T5, which is the encoder decoder model. So number of parameters are P and here are 2P.
Right.
But the computation which is taking place, like in the decoder model, input is both input and output, like you
Right.
mentioned.
So it will be 2p.
So your computation will be like 2x. And here also, if you calculate, it is approximately same 2x. That's why it is the number of computations is the same for both. And in the lecture, if you remember, the professor had given this is a homework to find out. Okay.
Sir,
So,
can you explain again, please?
so who was that again? Who had answered that?
But just give me just 1 second. Encoder decoder models, also the output is used as input in the encoder side, right? What is the number of computation increase there also
Where here?
in the encoder decoder models?
So this is the encoder decoder model.
Yeah. There are
Okay.
two sets of inputs, right?
So input, okay, you give input and you get the output. So how many computations are taking place?
But
One here,
the
one
output
here.
of that is going to the input, right?
Yeah.
T5 framework.
In the T5 framework. And in the T5 framework, Lavlinji, something was shared also.
Actually, one important thing which is missing over here is that there's a task to be done. Okay. And we are ignoring that task. The first answer, there was a female voice. I don't know who was that. That was moving in the right direction. See, there's a task to be done. So think about it that you're designing a model. T5 base work was in terms of how do you design an architecture. Let's say you want to design a model for doing translation. Okay. And let's say there are 10 words that have to be translated. The input has got 10 words and output also has got 10 words. Okay. So in case of your encoder decoder architecture, you will have these 10 words going into the system as input, and the output, let's say English to Tamil, the English words will be fed to the encoder and the Tamil words will be fed to the decoder during the training. Is that right? Does everybody understand that?
Yes.
Now, if you're using a decoder only model, then what will happen?
Will feed
You will
it
feed
both.
the 10 plus 10, 20 words on that side, on the decoder only, because you have to give both the English as well as Tamil, both the versions over there.
Makes sense.
Right.
So now, although your parameters is same, but your computation is actually dependent on the number of tokens. Okay, so if your number of tokens have become double, then your computations will be also happening. So your P computations on encoder plus P computations on decoder, let's say, or 10 tokens. Okay. So you have got 10x things happening on encoder and you have got 10x things happening on the decoder. That makes it 20x. Whereas in a decoder only architecture, you will have 20 tokens. You will have 20x. So both the sides you have got 20x, 20x. Okay. So the key thing here is that you have to design a system which is handling twice the number of tokens if it is a decoder only system. If it's an encoder decoder system, then half the input will be happening on encoder and half the input will be happening on the decoder side. So your number of tokens will be reduced that have to be fed at a time. That's why these computations are same. If the number of tokens are fixed, if both the architecture saying that only 10 tokens are there, then this equation will not be holding good.
What would be the scenario under an encoder based only? So
Pardon?
say the question also included an encoder based BERT model for translation purposes. Then only X is coming in, right?
The question is talking about that you have a decoder and you have an encoder decoder.
Yeah, I'm adding an encoder also model to the question.
If you have a single, if you have
Okay.
only a single one, you
No.
should keep in mind that if you have only a encoder only or a decoder only, and you have to feed English as well as Tamil, both the things to the input. Okay. If you have encoder decoder models, then you're putting half the things on one side and half the things on the other side. And you have to be careful that when you're saying that you will be generating, putting only encoder only model, and you have got English and Hindi, both the things over there. Encoder only models are not capable of generating text. They are only capable of doing certain activities. Okay, so that is something you have to be careful. But otherwise, your observation is right that the data that has to be input will be double the data which is going into encoder decoder. So main thing you have to look at that, are we having two different blocks or do we have only one side block only? Okay, if you have only single block, then your both the input and output labels have to be given into that single block only. If you have two set of blocks, then one input goes on one side and then the labels will go on the other side.
Okay, so what Lovelinji said, we have to remember this encoder model which is there, it does not generate any text. Okay, it just about the finding the probability of this masked words only to understand the bidirectional context. Okay, only the CLM generates the text and the encoder decoder also, because there is a decoder, it will generate a text. So that is
In the slides that we have been taught, we have also been taught that with the BERT model, there is a fine tuning where you can use it for, question and answer kind of scenario, where your question and answer both are given as inputs and they are separated by this separator token. Okay, and then answer is actually part of the input itself. So output will only tell you that token number 20 to token number 30, and that's where the output is coming out. It will be generating something along those lines. That I believe was part of the last quiz.
I remember.
Yeah, in week
Also,
4.
say if the task was not translation, it was just classification in this perspective. So in that
BERT
case,
is used for classification, and
Classification.
BERT is also used for extractive answering. Extractive answering is the word that you have to be remembering, because you are extracting the answer from within that paragraph itself.
yeah, understand that. I understand that. I'm just saying, if the task was only for classification, yes or no, right? So in that context, decoders and encoders would have only x plus 1, whereas decoder encoder model would have what, x 2x, the number of the number of inputs that are going.
But for that task, why will we use encoder plus decoder model?
No, I'm just
See,
saying, for an example.
Okay,
if this was a
okay.
question.
Think about it like this, that you have a 10-word input and then you have an extra token for classification.
Yeah.
So you have 11 tokens. You're designing a system of BERT which is capable of handling 11 tokens. Okay. Now, in case of an encoder decoder, if you have to design a system for the same capability, your encoder will have 10 tokens and decoder will have only 1 token.
Got it. Yes. Yeah.
So remember, this is about designing a system. This T5 is really about designing. Okay, so how do you decide what should I do?
Okay, shall we go ahead? Okay.
I think let's quickly look at the PYQ so that.
Yeah.
Yes.
So we go ahead with the VK just quickly.
Sure.
So VK, the first question is very easy. Consider the following large language models, which are the CLM and which are there. So BERT, we know it is a decoder only model. GPT, all are decoder. T5 is an encoder decoder. BART, we have to remember BART and T5. These are the encoder decoder. And BERT is the only encoder model. Rest all are decoder models. So that is you can remember from here. Choose. Okay, so these were the 3 questions on this. Choose all the aspects of the pre. Yes.
Just one more comment I will say.
Yeah.
I'll again say that you must know the full form of these model names. Don't be surprised that you're going for a job interview and they ask you what is the full form of this model. And if you're not able to say this thing, it turns them off. You may be thinking this is very, very trivial, but actually the entire meaning of that model is actually part of the name title itself.
Yes, thank you. Remember full form. Yes, because if you remember the full form, automatically you will come to know that what is the architecture. Am I right, sir?
Yes. So all your answers will flow from that one itself if you know the architecture.
Yeah. Okay. The second part is choose all the aspects of the pre-training data sets that impact the model's performance. So Straight away it has come from here, from the lecture. First of all, the quantity, that is the size, then the quality of the data set and the diversity. So these are the very important aspects of a data set for training. Next is directly from this formula. So from the quiz point of view, please remember this formula. NC by N, alpha N is 0.076 and alpha D is 0.095. N is 8.8 trillion
You have to memorize some of these constants.
and 54 trillion.
See, in quiz 2, there is very little scope for mathematical numerical calculation questions. And the handful of things which are appearing in the GAs or in the slides, I'm sure there will be questions around them. So wherever you see some formula on which, definitely make sure that you're able to answer it. And this question requires you to memorize some of these constants. Constants may not be given in the exam. I don't know whether they had given the constants last time or not.
They will not give. So important things to remember is 8.8 trillion, 5.4 trillion. Remember 76 and 95. So this becomes 0.0 and 0.095. This is NC, this is DC. Okay, and directly you put it here. This 1 billion parameters means a number of parameters. 1 billion tokens becomes D, and then you can calculate the loss. So this formula you have to remember.
Yeah.
And
I'm betting on the fact that since the GS did not have any question about sentence piece tokenizer, so we may not get any question on sentence piece at all
yes,
in the exam also, because they have not really been talking about it
yeah.
much.
Okay, then next question is also directly from the theoretical part only, that to get high quality context from raw data, what are the typical pre-processing steps involved? So we remove the duplicate content, toxic content. It is used by heuristics. Removing personality identifiable data, this is removed. Removing machine translated content, we remove placeholders. Example are these lorem ipsum. So these are removed. So this is directly from theory part. This is one important. We should know this pipeline, that how the data set pipeline look like. So what do we do? First, okay, I have mentioned here. So for remembering, first, okay, we do URL filtering. Then we extract the text. After extraction of the text, we do the language ID. After the language ID, then we repeat removal. For example, in many other URLs, same content might be there. So we remove the repetition removal. Then we do document-wise filter. After document, we come to the line-wise filter. Then we do fuzzy duplicate, and then we do exact duplicate. So this steps, okay, if you remember, this is the pipeline for data set preparation. So these steps, okay, we have to remember, memorize, and it is quite logical also. So if you make a story, then build a story to remember this. This will come handy. Okay. Then next is consider the following data sets for pre-training on LLM. This again is understanding. Book corpus was small, only 16 GB. Roots was around 1000 terabytes. C4 is the collection data set, 750 GB, and web text is 40 GB. So if you can memorize this. Select correct statement regarding Sangra. So Sangra is an Indian data set covered by the lecture. So it is a monolingual. No, it covers all the this. It has text from multiple Indian languages. Yes. It has no translated content from any other source. No. The professor has covered that we are using for the translation also. And it has only English text. That is no. So that these are the only questions. So straight away we can jump here to the PYQ if there is no question till now. Because all of them, they are theoretical. Can we go to PYQ?
Yeah.
Yeah. Okay. So PYQ has got some interesting questions. There are three teams, namely A, B, and C, decided to use a GPT model. So I will drop it off here first. Okay. They are going, length of the context window is 1024. So we know T 1024. Number of hats is 8. 1, 2, 3, 4, 5, 6, 7, 8. D model is 512. So this becomes 512. DFF is equal to 4 into model. So this is the, after this is the DFF. DQ is equal to DK is equal to DV is Dewey model by NK standard. The weights of the embedding layer and the output layer are shared. So here, whatever we are using embedding layer matrix and the output layer matrix, they are shared at both the places. They train the model on the pre-training data set containing 1 million words. So that is so many words they have trained. And after applying normalization and pre-tokenization using white space. So white space, where do we use? We used in BPE. Moreover, the data set has no duplicate sentences and no uppercase letters or words. Suppose the team prefers to use the BPE tokenizer to build the vocabulary and subsequently use that to train the model. The base vocabulary contains only lower cases alphabets A to Z, 0 to 9, and special tokens 3 unknown, go, and and. So your vocabulary base is size is A to Z 26, 0 to 9 10, and there are 3 are unknown, go, and end. So the first question is team A uses base vocabulary. So when the team A will use, so how his tokens will look like? His tokens will look like whatever he's passing. For example, I say, I am going home. I am going home. And this is 1024. This is 1024. So his tokens will look like I, A, N, G, O, like this up to E, and it will also have, it does not have this W, so his tokens will look like this. Is that okay with everyone? Understanding part? And then it will have pads. So here the pads will be there to complete 1024. Is that okay? Now the team B takes the vocabulary from this and it makes like a 500 merges. So when we do the merging, we know we keep on retaining them and the number of merges are there. So we will have this, how many were there? These were 39. So we will have this 39 plus 500 more tokens. Plus we will have also a special token called W. Is that okay?
In this
Why the
particular-
special token?
Because when we use the BPE, okay, sorry.
Yeah.
Okay, remove that again. Because already they have done.
no, actually, yeah. In this particular case, the answer that they are given in the PYQ, it did not include the special token of W.
Yeah.
But on the discourse that they had mentioned that they'll give marks for both the things. Okay, so people who included the special token or who did not include the special token, both of them are supposed to be awarded marks as per the discourse. Okay, but in their answer, this count it is not included in the count.
Actually, they have not used that you have to build the vocabulary using BPE, because when we use BPE in the initial only, this W should have come here, because W is always a token in BPE vocabulary.
No, actually, this question they're talking about BP should be used.
BP should be used, but what they have said, okay, that initial vocabulary which is there, the base vocabulary, they have not given this W, whereas in BPE, this W is always the part.
Yeah, in the base vocabulary, it will not be there because base vocabulary is actually, it is before this BP thing.
Yes, yes. Particularly in the BP also, when if we do the revision, so what do we do? For example, if I have got this, I am going home. So when we do BPE,
See, if you run the BP,
huh,
if you run the BP, then it will generate the W token as part of the BP activity.
yes.
Okay.
So it
So
will.
in this question, they have the answer that given is 1039, which does not include the W token. And on discourse, they mentioned that okay, 1039 as well as 1040 both are okay.
Okay. Is this clear okay, with everyone? Okay. Why the answer has come 1039? Because team A uses base vocabulary, team B takes the vocabulary and does 500 merges. So for team B, number of tokens will be 39 plus 500. With every merge, one new token is formed. One
Lalit,
new.
can you open that photo that I had sent you for this
Yes,
question? Do you have it
yes,
handy?
yes, yes, yes. Right. This is question in the first,
Yeah,
second.
first
Yeah,
one should be the first question.
yeah. This
Yeah,
one.
yeah. So over here, if you look at the base, you have got A to Z 26 plus
No,
0 to 9, 10,
sorry. Yes.
and then you have got special tokens. So that makes it 39. So for team A, it will be either 39 only or 39 plus W. But there are no merging happening there. Okay, so whether you do merging or do not do merging, W is supposed to get generated. Now, there is a chance that W does not get generated because there are no words. Typically the W gets generated because of the words only. So there is a little bit of ambiguity here, because even though the merges are not happening here, we are anyway supposed to run that logic, that whole process on that words, 1 million words. So W should be getting generated there. For all other cases, if they have given X number of merges, so you can straight away say that there will be X additional tokens which will be getting into the system. So in case of team B, it will be 39 plus 500 merges. That makes it 539. In case of team C, they took team B's number and added another 500 merges. So whenever you see that there are 100 merges, there are 100 tokens. There are 500 merges because every merge will generate one token. But this is something you can be sure about. W is the only thing that was not handled properly in this question.
So
Okay.
in this paper, they would be expecting us to take the W, right?
They did not. The PYQ was using answer as 1039, which does not include W.
Yes, but the previous session they didn't know, but like now we know, so it's better to.
I will say
Okay.
you should add it, because
Okay.
at least in the discourse they said, yeah, okay, both the things will be awarded marks.
Okay, I will just cover the basics of BPE, how the BPE starts here. So this is, for example, the sentence. So we do here only we mark a W. So and from here now we make the first walkup size. So what we will do, it will be I, then W, A, M, then W1 plus 1, 1 plus 1 plus M plus G, O, I normalization has taken place, so I will come here and G will become 1 plus 1, W will become 3, H 1 plus 1 plus O will become 1 plus 1, M will 1 plus, and E 1 plus. So this is your initial walkup size which has got W. But in this question, what they did, they have not given this W. Okay, and that's why in the next merges we cannot include this because this is not the part of the first. So this is the initial walkup. Is that clear? Now when we do the next merges, for example, in this case, how many tokens we have got? 1, 2, 3, 4, 5, 6, 7, 8, 9. So now next merges, with every merge we will get a new token. So after n merges, we will get 9 plus n tokens. Is that okay? Am I audible?
Yeah.
Yeah. Oh, yeah. Okay. So in this question, they have not given initial W here. That's why we cannot include this W later on, because this W cannot be, if it is not there, it cannot be included in the mergers. So with that, okay, 1039 is come. So main takeaway is that only, that every merge, new token. So that is the that. Okay, next question is choose the correct statements about the number of parameters in the model, excluding the embedding and output layer. So just give a thought again. So A, B, and C, your number of parameters, they will remain same, or they will be different?
Yes.
Okay. Why it will remain same? Because the only change will happen that I had covered, like example, A will have I, A, M, like that, and pad up to 1024. B will have something like I, M, G, O, I, N, G, something, pad. And C will have something like I am going home, pad. So this will remain same, and your parameters which are there for all A, B, C, this will remain same. So that is the from the conceptual point of view. Now, second, assume that the word acrophobia is not present in. Yes,
I had
yes,
one question.
yes.
So this is happening because we are sharing the input and output layer. If the output layer, if we wouldn't be sharing, then the output layer would be different, right? It would be the number of vocabulary, like
Okay,
Anama.
so your vocabulary size which is there, this is your input, and this is 1024. For and you have been given, for example, D model is 512.
Hmm.
Now your walk-up size embedding layer which is there, it is being shared. You are right, okay? Because they have written that, okay, this both are shared.
Yeah, if it wasn't shared, then there would be some difference in the parameter,
Yes,
right?
yes, they will be different, okay? Because then your walk-up will be different for both. For A, walk-up will be different. For B will be different, and C will be different. Am I right, Laviji, with this?
Can you say it again?
What he said, that in this case they have
We're
said
still
that
we're still on the first question, or are we talking about this second question of sharing that things?
we have come to that, okay, first. Okay. The number of parameters, is it understood? Number of parameters will not make any difference. Embedding layer is the same. Output layer, okay, they are sharing. The parameters, they remain the same.
Okay, just a minute. Let me open this PYQ at my end because your text is very small. So we are talking about that model A has less parameters than team B. Model B has got less parameters. Team C. You're talking about that
Yes,
question.
yes. And the part is that all models have the same number of parameters.
Your model parameters. What is it that we consider as model parameters? Typically, is your QKV things.
And embedding layer also, and output layer also, and in between FFN also. So FFN is fixed, okay?
Yeah, FFN is not dependent on this one.
Yeah.
And if you look at that, in all these cases, your D model remains the same. Your DQ, DK, DV, they also remain the same. Okay. So when it comes to the number of parameters of the transformer block, they are actually shared across irrespective of whatever is the vocabulary, it remains the same one. Okay. And so there again, one of those ambiguities come up, that are they talking about only the transformer block, or are they talking about the full model? So this is something is not clear here, because over here, when they're talking about their same, that means it is excluding the embedding and the output layers, and it is not dependent on the vocabulary.
Yes.
So these are one of those questions where they have very clearly mentioned that it is excluding the embedding and output layers. But if they have not mentioned it, then answer should have been different.
Yes. And so is this okay? Okay, this part, okay?
No, yes.
Okay. So assume the word acrophobia is not present in the vocabulary, then which of the following tokenizer is guaranteed to tokenize this word into subwords, units, and it does not return unknown. So again, like, what we can just go conceptually. अगर एक्रोफोबिया आएगा तो जो ए है ए का क्या बनेगा लाइक दिस इज दिस ओके and pad for example is this okay
Yes.
in B some merging has taken place so what can happen you can get okay, for example ACR OBH IB IA and pad and C further merges will take place for example ACRO BH oh sorry O will not come here ACR OBHIB IA. So this might happen and pad. So in no scenario you will encounter unknown. Is that okay?
Yeah.
Yeah. So in all cases you will not have any unknown. Okay. Now we go to next one. Assume that team A and team B pre-trained the model for 1 million steps. Suppose they want to fine-tune the model for sentiment classification task, where the data set contains sentences, digits, and emojis. Choose the correct statement. Team A can use the tokenizer from Team B and fine-tune the model and vice versa. Is that correct or incorrect? Just use some concepts okay, till now what we have covered.
They both have the same parameters, right? Same number of parameters.
Yes.
So,
And put an output as a shared, so yeah, they can.
So see, my understanding, like how I approached okay, this problem, that this is a GPT problem, GPT. So it's a decoder only. We are giving some input. The length is 1024. The D is 512. Here is the embedding layer. Embedding layer. This is the output layer, output matrix. These are being shared. Now, what happens during pre-training? Pre-training, we are just passing one sentence and then we are training. So what have got trained? Your FFN has got trained. Your Q, K, Q, V, O, and your output layer and embedding matrix, they have got trained. So these are the trained things. Now, in case of A, B, or C, your size of FFN, K, Q, V, O, and E, M, and output layer, they remain the same. Is this okay?
yes.
Okay. So now during pre-train, for A, some parameters have been learned. For B, some parameters have been learned. For C, parameters have been learned. So these FFN, K, Q, V, O, E, M, and output which is being shared, they might be different. The values might be different. So what happens okay, during fine tuning? If I take the tokenizer of A also and then do the fine tuning, what will change? Only your these parameters will change.
Right.
Similarly, if I take B, only these values are changing because the size remains the same. So with that logic, that was my approach. That's why I've analyzed कि yes, okay, these they can be done okay. Lavlinji, that was my approach okay. I have covered okay, this question.
So this question actually has got partial information, and a lot of people lost marks because of that partial information. If they're only changing the tokenizer, then this will not work. Okay. And the missing information was that it is not just the tokenizer, but the embedding matrix is also being shared between A and B. You cannot feed team B's tokenizer into team A's model. The code will not work at all. Okay, so in this particular case, the missing information is that it is team B's tokenizer plus team B's embedding matrix plus team A's transformer block.
Okay, so what Lavlinji has said, okay, I will amplify here that why that relevant part is correct. Okay? So we again go back to the our last question. So what we had seen that, for example, this A is there and it is using only basic vocab. So the tokenizer size is 39 only. Here it does for 500 times, it does 539. This does 539 plus this, so it becomes 1039.
So
So
if
for all, your walk-up size will be different. Will be different.
yes,
Okay. So if your walk-up size is different, then your embedding layer, which is there,
also be different.
will also be different.
So you can write the dimension of the embedding matrix for A and B.
Okay. So what will be the dimension of walk-up size for A?
What is the D model? D model is how much?
512.
So 512 by 39 and 512 by 539 and 512 by 1039.
Okay. So this is the embedding matrix. Sorry. So this is the question of debate because the embedding matrices which are there, they are different.
So if you have a team B's tokenizer, which is giving you token ID number 501, it's not going to TA's embedding matrix because it is expecting token IDs between 1 to 39 only.
Right.
The
So
matrix multiplication will not work. If you're using team B's tokenizer with team A's embedding matrix, the matrix multiplication will not work. So the hidden information over here was that they're using team B's tokenizer and the embedding matrix. Both.
So both tokenizer and
See, once
embed,
it has passed through the embedding matrix, then your output is 512 in all three cases.
yes, to be shared.
So yeah, so this 512 then can be used with the model, but 539, 39 or 1039, that's where the incompatibility is there.
Okay, is everyone able to grasp this? What is the issue?
yes.
Yeah, okay.
Yes.
Okay, that's very nice. Okay, then, okay, next question. Again, it is conceptual. Suppose we have two decoder only models. So this is a decoder only model. Model A, model B. Assume we have two data sets, one for unsupervised pre-training web text, the other for supervised training text summarization. Model A was trained directly on the training set of the supervised. So this model A, which is there, it has been used for supervised. So how do we supervise it here? We pass the input, we take the summary, does the loss, and we update the parameters. Model B was trained on the pre-training data set using CLM objective. And model B what using? Model B is using only the CLM. So it is generating the next token, and it is updating its parameter. Okay. Suppose we want to test the performance of both models on the test set of summarization task. So this has been tuned on supervised modeling. This has not been, it has only understood the context. Till now, everyone with me?
Can you repeat
Yeah.
the last part, please?
Okay. Okay, so I'll cover. Okay. So what is the meaning of the question? Suppose we have two decoder only models, namely model A and model B. So this is model A. This is model B. Assume we have two data sets, one for unsupervised pre-training web text. So in this case, there is no label, web text, no label. The other for supervised training, text summarization, where we have got text and we have got summary. Model A was trained directly on the training set of the supervised data set. So model A, we are training on supervised data set. So what we are doing, we are passing the sentences and we are getting something and we are finding the loss with respect to the summary. We flow the loss back and we train the parameters. Is that okay about model A?
Yes, yes.
Okay. Model B is just using CLM objective. So it is just passing the input and using the CLM, whatever the output is coming, you are comparing with the next output, and that's how you are updating the parameters, the CLM. Is that okay?
Yes.
Now, suppose we want to test the performance of both models on the test set of summarization task. Now, I have got model A, which has been trained on this summary, model B, which has got the context, and I want to test the performance of both models on the test set of summarization task. Okay. And what are the options? These are the options. Model A can directly be used on the test set. Why it is true? Because it is already trained on supervised task. Is that okay? Okay. Now, model B also can be used directly on the test set without fine tuning. Why? Because this is from the lecture that when you train a CLM model on a large data set, then it can be used for zero shot downstream tasks. And this summarization is from that only. Now, Lavlinji, can you just amplify more on this one? We had discussed it just now.
Yeah, this is right. It's coming from the GA also, that these large models are good at zero shot and few shot things. So it is not mandatory to train it. You can train it, you can do a fine tuning, but fine tuning is not necessary. So that's why the third option is marked as wrong, because it says it should be fine tuned. Okay, so for model B, fine tuning is optional. It is not mandatory. That's why second option is correct and third one is wrong.
Okay, it's clear, everyone?
Yes.
Yeah, okay, very nice. Okay, we go to the next. Okay, so this question, the answer is incorrect, okay, and it is directly from the GA, and it is about the Sentinel. We have seen, okay, how the Sentinel ones are done, and already we had done the discussion. Okay,
Yeah,
in
so
the
these PYQ options are wrong, so don't go by PYQ options.
Okay.
Okay.
Yeah. Then we come to which of the following models uses a form of denoising objectives. So remember denoising, when denoising is used, when we are using mask or what we are doing, we are distorting the input. So where do we use that? We use it in BART, we use in BART, and we also use in T5. So these are the
So
three.
where there is encoder only or encoder decoder, we'll use denoise.
No.
No,
Don't
No.
go by that one.
it's
Okay.
not that.
Okay.
Okay. I had
Yeah.
shown you a document in the beginning.
Yes. Yes.
That document is telling you. So it depends on, how you're training the model.
Okay.
Okay. So in case of, see, if you see, look at, strictly speaking, the denoising objective was there for BART and T5. Okay.
Okay.
Now, MLM is something which is there in BERT and it
Right.
is there in the T5 and BART also it is being used. And the tricky thing here is they're not saying denoising is the objective. They're saying a form of denoising.
Okay. Okay.
So even I would have done it wrong because they are these small things, a form of denoising. So important thing is T5 should definitely be click T5 and BART. And about BERT, people may be having different, opinions because often we are using MLM as the objective.
Yes.
So there's a vagueness, in the terminology there.
That's
Right.
why they have used like a form of. So masking is also form of.
Yeah, so it is easy for us to, comment on it now.
Yes,
But
yes.
if you don't have the answer, then
Yeah.
definitely all of us will be doing it. I will definitely would have skipped that one.
Yes, yes. Okay. Next, okay. Consider training an encoder decoder model. Say decoder only with task. Say T5 baseline. So this is wrong. Encoder decoder model T5 baseline on a pre-training data set that contains 1 billion tokens. Let the batch size will be 64 into 128, that is 202 to power 13 tokens. Suppose the model is trained for 2 to power 15 steps. By varying the size of the data, then A is train the model only on the first 1 million tokens, referred to as model A. B is train the model on the entire data set, referred to as model B. Which of the following statements are correct? So, like we had seen earlier, so I'll just cover the basics of this. How do we approach this problem? So we know the data set size is 1 billion tokens. So 1 billion is 1 to power 9. Two, three, five, three, eight, 9. 10 to power 9. Okay. Let the base size 64, 128, that is 2 to power 13. Suppose the model is trained for 2 to power 15. Train the model only for the first 1 million tokens. So in one full cycle, how many tokens it will see? 2 to power 15 into 2 to power 13. Is that okay?
Yes.
Number of tokens. Now we know what is 1024 is 2 2 ja 4 2 ja 8 2 ja 16 32 64 128 256 516 into 2. So 2 to power 10 is 1024. So 2 to power 28 will become how many tokens will be there? 2 to power 10, 2 to power 10 into 2 to power 8. इसको भी आप 1024 लिख लो. So approximately it is saying 1000, 1000 and 2000. So approximately if you see, this is also around 1 billion. 1 billion. Now in A, the model is trained only on 1 million tokens. It means the A which is there, it will see every token how many times? 1 billion divided by 1 million is equal to 100 times. So what will happen? Your A will have overfitting. Is that okay? B will see every token only once. Is that okay?
Yes.
Okay. So the next part is come. So when overfitting happens, what happens? The training loss becomes less. Okay. So model A training loss will be less than the training loss of B.
Right.
But due to the overfitting, the test loss of model A will be higher
Higher.
than B. Is that okay?
But it is not that likely. What if the model underfits?
It is
If
not
we
underfitting, na. It is seeing
if
every
by
token.
chance there is underfitting, by chance there's underfitting on that token,
So when it underfits, so your training loss becomes higher.
training loss becomes higher.
Okay, but
This is
your
alpha behavior.
test loss is not higher. Okay, in the case of underfitting.
No.
Okay. So they are just checking this concept only, that how many tokens, okay, we are seeing, and overfitting and underfitting.
Got it.
Yeah. That's okay, Lovelinji? Okay, and exactly I had calculated this
Yes, that's right.
yeah. And for B, the number of tokens is less than 1 billion. Okay. So my calculation here, it is incorrect. You can do the mathematical calculation. So now to increase the training steps, okay, will help model B. Then model A. Model A, what it will happen? More underfitting. Okay. That's why this option is correct. Baki actions increasing the training steps helps both model and model B. No, model A is not. None of the given modification helps the model to improve. No, the model B is helped. Okay. So concept is okay, your number of tokens seen. Now consider a summarization task. Assume the prefix is summarize the following. So this is the PLM model, prefix language model. Here is prefix. This is sentence. And the input sentences, there are a lot of videos on YouTube, this, that, blah, 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 blah. Then which of the following architectures could be used for the task? Lavlinji, can you explain this part, okay, please?
Let me just open this. Okay. If you look at what does a decoder only model do? It is generating the text. Can you hear me?
Yes, now we can hear.
So if you're talking about, see, whenever you have a decoder involved, okay, it is capable of generating the text. Okay. So when you want to do a summarization, your generation becomes very, very important. You cannot do generation without, you cannot do a summarization without the generation ability. So your decoder only model, your encoder decoder model, both of them have ability to do the generation. Whereas ENC only model does not have the generation capability. So it will not be able to do the summarization activity.
Okay. So this is the, again, from the same concept, that the encoder model can only predict the masked words. It cannot generate. So these three, decoder only with the prefix model, and encoder decoder, this is the correct option.
See this prefix, do you understand what is the prefix mask? This is same as giving a prompt. Like in case of T5, you are saying summarize, that is your prefix. Or translate. So those keywords are your prefixes. So that's the only difference between this prefix and CLM thing.
So, sir, is it necessary that the summarize part will be the prefix? Like the action part
No,
will be the prefix.
no. You are giving an instruction.
Mm-hmm.
Instruction could be one word saying summarize this,
Yeah,
translate this.
right.
That is what is referred to as a prefix.
Okay, so the prefix could include some words. I'm saying that I'm asking that. Is it possible that?
Yeah,
That
prefix is your description of the task. It is the instruction.
Can have code secure for that.
okay.
Okay. Okay, next is also regarding that overfitting and underfitting only. Suppose we are given a model A with n layers and the data set with d tokens. Choose the correct statement according to the scaling law. Increasing the model size requires a proportionate increase in the data set size to reduce the test loss. This is okay. If we don't go by the scaling law, also scaling law was nc by n by 0.076, 0.095 plus dc over d to power 0.095. But in case okay, we forget this formula also, remember that if your data set size is fixed and you increase the parameters, what will happen? Your overfitting will take place. So if you are increasing the parameter, you have to increase your data set. Okay? Is that logic? This holds good?
The important thing over here is this scaling law is applicable to the test. It is not applicable to the training. Okay, so this is something you may forget. So if they're talking about the training, you have to rule it out. Okay, and you can memorize this statement that you have to increase the parameters and the data, both of them. It is not just one of them, you have to increase both of them. If you
Okay.
increase data too much, but the parameters are not there, then the model will not have the ability to learn. If you increase the parameters but data is not there, then it will be overfitting. So both of them have to be increased. And this reduction of loss is applicable only to the test part, not to the training. Because when you're doing overfitting activity, the training will be going towards a zero. So it is the test loss that we are interested in improving. These models today that we are using, all of them are actually overfitting, because the sufficient amount of data is not there which can be used to train them.
Is that okay? If we increase the parameters, keeping the data same, overfitting means training loss okay, decreases and the test loss increases straight away from our machine learning foundation. So as we increase the parameter, we have to increase the data. And now we reach the
There's
this.
one more thing I'll mention, and one of the previous questions, it was relevant. If you have an overfit model and you increase the number of training steps, it is going to worsen the situation. It is not going to improve the situation.
Yes. Why? Because it will memorize. Is this okay with everyone? This concept?
So we have overfit model and we are increasing the steps only.
Yeah. So again, what will happen? It will overfit more.
Right.
Okay, memorize. So it will worsen performance.
So in that case, we should increase the data size.
Data size.
See, think about it that you have a 2D data and there's a curve. And initially you're fitting this curve with a straight line.
Yeah.
This is your underfitting. The straight line does not fit the curve. Okay, we also say model is biased because you're biased beforehand. You have decided that straight line is the right model without looking at the data. That's typically we do in linear regression. Without looking at the data, we decide that straight line is the right thing. Now, as you increase the number of parameters in your model, this straight line will slightly start curving. So it will be fitting your data slightly better. And if you keep on increasing the number of parameters in the model, it will start adapting itself to the data. That's where the overfitting starts happening. And then as you keep on increasing the parameters, suddenly it will start touching each and every data point. Okay, it is not supposed to be touching each and every data point, but it will start touching each and every data point. So your more parameters or you're doing more and more training, it is going to increase that overfitting activity.
Okay, it is like this. Okay, what happens is, okay. Next question is again from that toxicity. How do we remove the pages that contain bad words? So it is done by simple heuristics to detect toxic contents. Rest all options are incorrect. Language ID, exact duplication, fuzzy duplication, ML classifiers, nothing is there. Then the next question. Suppose a team wants to build a data set for low resource language. So low resource language means that there is very less data about that language. For example, Tamil or any other Indian language, Assamese. They took all Wikipedia dumps for that language and found that the dataset size was insufficient. Then the statement that using years of common crawl snapshots would be helpful. So what is a common crawl snapshots? Mainly it means that every month or every year, whatever the web dump is there, they keep on dumping. So every year or every month or on a regular basis, it has got new content. So when we use this, definitely we will get more data. So that is statement is true. Is that okay? This was covered during the lecture also by the professor.
See, like T5, C4 is another term that you should know what is its expansion, because T5 uses C4. Okay. So C4 is a data set. It will be good to remember its full form.
Yeah.
Even I don't remember it fully, but it may be common crawl, curated, or something like that. It may be there. It is a cleaner version of that whole data that they have extracted from the websites.
Okay, the statement that the presence of significant duplicate contents in the pre-training dataset degrades the performance of the larger language model. It is true. Because if there is a duplicate content, then the same token you are revisiting again and again your model will overfit and your performance will decrease. That is the last question. Any question on any query on any topic till now? Anyone? Okay. Ashutosh?
Did we confuse you, or did we clear up things?
Hi Abir, I hope it was helpful. Abir?
Abir is not there.
Yeah. Okay, so I'll stop recording.
Yeah, Abir is there.